Hello, welcome to the second lesson in a series on microtonal guitar. So today we're going to look at musical ratios and the harmonic series. So I've got a monochord here. These two bridges are set at 100 centimeters apart from each other, or 1 meter. And basically, I just want to go over the basics of the harmonic series and how we derive musical ratios from the harmonic series. Okay, so whenever we strike a string, right, there's a fundamental pitch or the first harmonic that sounds, and then there are a number of other pitches that are sounding that are all sounding together to create that pitch, right? And so those happen at we call nodal points. So if we divide the string by 2, by 3, by 4, if I divide the string in half and go to that point and lightly put my finger on there and pluck the string or tap the string, we get another pitch, right? If I divide it by 3 and do that, so like I said, I'm 100 centimeters, right? So this would be 50 centimeters, 33 centimeters, right? So divide it by half, by third, by 4, that's 25, right? So 1, 2, 3, 4. Okay, those are nodal points. Those are the first harmonics in what we call the harmonic series. Just a quick aside, you'll hear people also refer to the overtone series. A lot of times I see the term used synonymously. They are a little bit different, or they're, definitively different, where with the harmonic series, the first harmonic is the fundamental pitch. In the overtone series, the first overtone isn't the fundamental, it's the second harmonic. So they're not, the terms, even though you see them used synonymously, they're not synonymous. They're very definitely two distinct different series of notes, right? The overtone series starts on the second harmonic, okay? So anyway, sorry, I just want to make sure, because that can get confusing when you're reading when you start getting into tuning literature and stuff like that, you'll see people sometimes use those terms and it's confusing. So let's go back now to those first 4 harmonics, right? So we've got 1, 2, 3, 4. Okay, let's look at the relationship of those, so to each other, right? So if I've got this note here, and it's beating at 130 cycles per second, this is tuned to C at 130s, equal tempered C, 130.8 cycles per second. And now I divide it in half, right? And I get that nodal point. Now this nodal point, this pitch is beating twice as fast as this one. So it would be 261.6, right? Sorry, 260.16. So this is beating twice as fast as this, okay? And so we say that relationship is 2 to 1, right? The relationship of an octave, and these are an octave apart, right? So whenever you have something that's beating twice as fast as something else, those two pitches are an octave, what we call an octave in Western music theory. And the ratio for an octave is 2/1. Right? Literally, the pitch generated from the second harmonic against the fundamental or the first harmonic. Okay? So let's go to the third harmonic. Now this is beating 3 times as fast as this, and it's in a relationship to this pitch of 3 to 2. So if this is 130.8, let's just round it off to 130. If this is 130, this is going to be 260, and this is 390, okay? So when I say rounded off, obviously that's pitch would be different, but I mean just we're rounding it off to to be able to do the math easier. Let's even just divide it. Say it's 100 cycles per second, right? So this is 100 cycles per second. This would be 200. This would be 300. Now this pitch is a G from the fundamental of C. So we've got C, D, E, F, G. So that's the fifth of C. In Western music theory, we call this a fifth, okay? So the musical ratio for a fifth is literally, 3 over 2. This is 300 to 200. Or 390 to, 260, or 130.8 times 3 over 130.8 times 2, right? So now let's move up to the next note, which is the fourth harmonic, which is going to be, an octave of the second, right? So here we go, 1, 2. Whenever we double that 2 to 4 to 8, we've got an octave, right? And just an aside, each time we double the octave, there's going to be a bunch more notes in between it, right? So we go, there's no notes between the first and second octave. Now there's one note between the second and third octave. And then there's going to be 4 notes between the fourth and eighth harmonics, right? And then 8 to 16, we'll talk about this another time. There we got what's called nature's scale, 8 through 16th harmonics. That's where you see the first, more than what in Western we term as a scale, right? So getting back to the fourth harmonic, right? So this is an octave. So what's the relationship between a perfect fifth or a fifth and the eighth scale note, eighth scale degree, or the eighth, or an octave is a perfect fourth, right? So we've got, so this is G, this is C, G, A, B, C. And so what does that mean? The fourth, what's the ratio for a fourth? 4 over 3, okay? So let's review a little bit. I'm going to stop here. The next lesson we'll go into inverse string proportion and how the length of string relates to pitch, right? And intervals. So let's just do a quick recap here. So the main takeaway here is how musical ratios relate to the harmonic series, right? So the second harmonic over the first harmonic is an octave apart, and we say the ratio for an octave is 2 over 1. Whenever you have something beating twice as fast as something else, they're in a relationship of 2 to 1. When you have a relationship of 3 to 2, the pitch generated from the nodal point or the harmonic, when you divide the string in half, which is the second harmonic, in relationship to the nodal point, the pitch generated by the third harmonic, those have a relationship of 3 to 2. This is beating 3 times to this 2 times to this 1. When you have a relationship of 3 to 2, we call that a perfect fifth. Our fifths in equal temperament are not pure, they're not 3 over 2. They're slightly off. Of course, we'll get into that. That's what we're building towards. But just also recognize that, this is pure music theory. This isn't equal tempered music theory, right? We don't use a system that's based on the overtone series, hence what we're building towards. The fourth harmonic against the third harmonic is a perfect fourth. That's the relationship of 4 over 3. And it's the difference, or this relationship between the third harmonic, which is a perfect fifth, and the fourth harmonic, which is an octave. So what scale degree is from 5 to 1 is a perfect fourth, or is a fourth, or we call it a perfect fourth. And that fourth has a musical ratio of 4/3. Okay? So feel free to let me know if you have any questions below, and